Hi everyone. Today we're going to work on putting together all of our probability distributions. We did 4 different kinds. So I just want to spend today just kind of going back over. I created this chart for us to kind of summarize everything that we've done in the last several days. Hopefully by the time we get done with this video that you kind of have a better understanding of all 4 and how to pick out which one to use when. Okay, so the first one was the original probability distribution. So if you think of this one as all of them, this is the one that's like covers all the different distribution, not just the ones we did, but there are more out there. This is the big umbrella. Okay, and there are the criteria that you had to be, the total of the probabilities had to equal 1, and the probabilities had to be between 0 and 1. We created an XP of X, or probability distribution chart. Our graph was a bar graph. And when we talked about expected value, that meant the mean. So over here in the formula column, I have all the formulas that you would need. Now remember, mean, variance, and standard deviation, we made that chart. So that chart I gave you. So how do I know that something is just a regular probability distribution? This is when usually I give you a frequency chart. So this was like the number of car accidents, the number of goals in a soccer team. So it might look like this, that I have given you a t-chart where we have our random variable x, and over here was the frequency. And you had to create that p of x column. Okay, so these two I'm giving you, you have to create the p of x, and then from there find the mean, variance, standard deviation, answer some probabilities, probably make a graph. Then we went on to talk about a binomial distribution. So remember that binomial, we have a set number of times we're doing it. There's only 2 possible outcomes, a success and a failure, and every single one of these trials is independent of each other. All right, so you have like N, P, Q, and X, and we talked about how to identify those. So remember that X is the random variable going from 0 to the number of trials. So remember we had a formula, we could either use our calculator, and then you had the online calculator. And then there's the mean, variance, and standard deviation. So remember binomial, how are we going to do this? That there's only 2 choices. And that when we're looking at this, we have a set number of trials. And that's one way, definitely to be looking for, that's how we're going to differentiate that between that and a, let's say, a geometric or Poisson. That I'm doing this 10 times or 5 times. Like I'm only doing it a certain number of times and there's only 2 possible outcomes. Then we talked about geometric. And again, we have this independent probabilities the same for every single trial, but differentiating between geometric and binomial is that I'm going to keep doing this until I get to a success. So the key here is that we're going to keep doing the trial until we have a success. So unlike binomial, where it's like I'm doing it 5 times, here I could be doing it 30 times and then get a success. So it's keep doing, there's no set number of trials. All right, so we still have the P and Q and the random variable. And difference again, random variable starts at 1, not at 0. We have a formula. You have geomet PDF, online calculators. So you have a couple of choices, and then you have your mean, variance, and standard deviation formula. Now, Poisson was different because it was not a success and failure concept. It was occurrence in a set area, volume, or time. All right, so the way we're going to distinguish Poisson between the other ones is that the average is given in the problem. Okay, so we're going to look for if it says average or occurs this many times, that's going to be a Poisson. All right, so those are going to be the easy ones to pick out between all the rest. So what I have here is a series of problems which I will upload the answers to. You're not going to quite get them right now, so you can practice. But I want to go through and talk about how we can tell the difference between several of these. And there's quite a few here. There's like 7 problems. But again, you have access to the online calculators and so on and so forth to help you out. All right, so if I look at the first one, we have 400 laptops. Each laptop has an 8% probability of working or not working. We randomly select 20 and for your salespeople. So right away, I see a set number of trials, which is 20. And I have a success rate of 8%. So to me, this tells me this is a binomial problem. Okay, so if I want to know what is the probability of x equals 5, I'm going to go to my binomial, I'm going to put it in, and I'm going to set that up so I can solve it. And then that they all work, so I'm looking at probability of x equaling 20. Okay? All right, so let's try the next one. A study indicates that 4% of American teenagers have tattoos. You randomly select 30. What is the probability that exactly 3 have tattoos? Again, I want to look at, is there a set number of trials and do I have a success or failure? And the answer is yes. So again, this is going to be a binomial problem. Okay. All right, let's take a look at number 3. On average, Friday, a waitress gets no tips from 5 customers. Find the probability she gets no tips from 7 customers this Friday. So in this particular problem, there's no success, there's no failure, but I do see that we have an average of 5, which tells me that this is a Poisson distribution. So I would do that accordingly. All right, so why don't you pause the video and see if you can get the same type of distributions like I'm going to. Okay, take a minute, work through and see if you can figure out the type of distribution. All right, let's see if you got this right. This one says it right in the problem. Okay, so this is a Poisson. And even if it didn't say it in the problem, it tells us in the problem that it gives us a mean of 7.6. So that tells me Poisson right away. Among 25 employee women, suppose we randomly sample 25. Okay. All right. So what is the probability the first woman who says she has never been married is the 4th woman? So this is about when does my first success occur? So that makes this particular problem geometric. Okay. Blood type. Probability of 0.25 of getting 2 O genes, so having type O blood. Different children inherit independently of each other. We wish to find out the probability that the first child, these parents with type O blood, is their 3rd. This is geometric because my first success is going to occur at the 3rd child. Okay, and then this one, this is our last problem. It tells us right in the problem that the average of 4 new cases. So this is a Poisson because it tells us the average in the problem. All right, so hopefully this helped you out to determine which type of distribution you're going to use when. There's tons of practice problems here as well as in the review. If you have any questions, please let me know. Stay safe so we all can be well.